Okay, let me restart with the next chapter of the program, analytical geometry. Yeah, we have just 2 slides, and then I already uploaded in my study the next presentation with exam exercise and so on. We have also here an exam exercise, just to recap, more than exam exercises to recap. Look here. Definition of a point. Now, do you remember? I already told you this, the beginning of the semester. A point is a vector, at least in our language, in our course, a point is a vector, or please pay attention, n tuple in R up to n. This means the point is characterized by, let me say, n coordinates. N tuple. Do you know this language? Anyway, it's a vector with n dimension. We have also a different definition of point. Let me now introduce the definition of a line. Let's consider P as a point. We know what a point is. A point is a vector in our language with n components. Be a point, and a non-zero vector basically is given a point as a vector. Basically, is given to vectors. It's given to vectors. Nevertheless, we see that we have the difference between a point and a vector. A vector is characterized, excuse me, the point is characterized or can be seen as a vector. And a vector can be seen as a point, but can be associated to a vector something more. Let me show you. Because here it seems to be that they have 2 vectors. It could be. I can say so. Let me go ahead. A line through the point P and parallel to the vector A is the set of the points L through P parallel to A. We can read this expression here. Equal what? A set. This symbol here can represent a set of what? Of characterized by the point P, and please pay attention, plus T multiply A, in which T is the parameter which belongs to R. We can say in more compact form, that's the line passing through P parallel to A is P plus TA. It's a little bit abstract, but when we apply this definition, it's extremely easy to build the line. This means it's valid if I say I have a 2 vector. Of course, it's valid, but one of these 2 vectors is used as a direction. I don't know if you remember the concept of parallel, opposite. You remember this? I will come back on this, but I already defined the word parallel. No? I already defined opposite or with the same direction and so on. This means if you remember the concept of the parallel, parallel are 2 vectors. If I consider 2 vectors, you consider so n vectors, doesn't matter what. It could have the same direction, but also the opposite direction. I don't know if you remember the definition. And here is characterized here by this T, because T does not belong only a positive value. Could be positive, could be negative. This means it is valid if I say I have a 2 vector, of course, but one of them, in order to define a line, I use a direction to introduce the concept which I already defined, the direction in the new concept, which is the line. Please pay attention that each definition is useful, and we use definitions to define, to give the formal expression for a concept. Until now, we didn't have in mind probably yes, but in this sense, we need a formal expression, let me say, which I can work in, which I can later generate in the algebra or in the geometry in this case, in the formal form, in the formal way. This means here in this definition, we have a point, which is a vector. We have another vector, but used as a direction. Could be opposite, could be parallel, because T belong R. Positive could be negative. We can see in this course we have a nevertheless to learn. We have a nevertheless to learn the meaning of the math. Why definition? Why I can find another way, of course. But if you define another way, I mean, now we will see in the possible application. This is a definition which helps to understand or to describe some phenomena, but probably not very well different phenomena. Let me go ahead and we will about the application we will see later. I need a few minutes to go ahead with the second presentation on this topic here. The definition ends with the last sentence, which basically characterize the concept, the sentence try to describe the concept of belongingness. We say that the point Q belong or is on the line, is on the line, belong to the line, L parenthesis B semicolon A and so on, if Q equals P plus TA for some T. This means there exists some parameter in which Q, please pay attention, is in a linear combination of what? Of two vectors. Because point is in a vector. This is valid. What is the meaning of belongingness or is on the line? Let me read exactly. Is on the line. This means belong to the line. Belongingness. If in the definition means if and not if, no? Goes in both directions. If Q is in a linear combination of these two vectors. It's clear, huh? Because I can get Q combining P and A. This exists something. This means the linear combination we can see also in this definition here. Exam exercise. Try to do a lot. Here we have the solutions. Yeah, I have. 1 minute for you, and then we will discuss together the solution. This could be an exam exercise, just to introduce the topic, and then please download if you want the lecture in my study, but you don't need it. I tell you. We have also exam exercise. This is one of them. Example. Every example in which is here could be also an exam exercise. Of course, in the exam, I didn't put P1, V minus 1, minus 2. I will put different. But once done is, yeah, we have also the graphical solution. But now what I intend as an exam exercise to calculate the solution. Find a line passing through point 1, 1. Is a vector, yeah, but does not characterize this. Does not characterize the direction, because the direction is characterized by the vector V. Again, a point is a vector, but as a point does not characterize directions, but can be seen as a point, as a vector, excuse me. As a vector is the point, but as a vector can be seen as a direction. Fix the concept. P is the point. V, which is the vector, but does not indicate the direction. A direction is indicated by V. Did you have these results? If you do, did you do the example, the exercise? No. Apply the definition. What is the definition? Here. The line excuse me, is P plus TA. Too difficult? I'll show you the solution. But I would like to emphasize, in math, math, in my opinion, is easy, at least in the exam, because you have a definition. You have to apply the definition. I have P, I have A. In this case, it's V. Now, A is equal V, the vector. I changed the name. A is V now. Okay. P remains P. Look here, as easy the solution is. I don't know if I share. I hope that I forget to share every time. I share now. How is the solution? Just apply the definition. The set of the point characterized by the point P and the direction V, which I called here L parenthesis P comma V parenthesis equals. From the definition is P plus TV. Did you agree? No? The definition was T multiply A. Doesn't matter. Yeah. I change the notation with intention because you don't have to fix with the same nomenclature. No? V is the direction. Or better to say, V is the vector. But vector in terms of direction, because P is the point. A little bit the words, but I don't know if it's clear what I intend. Now, P we know is 1, 1. P is 1, 1. I gave you. Otherwise, we cannot do the exercise. Plus T, which is a parameter, the definition, say, for each T belong to R, positive or negative, which multiply our direction or vector in a proper vector, no? Because the point is in a vector, but not properly in the sense a vector is more than one point, than a point. A point is in a vector is more than. Could be also directions, no? Look. Now, please pay attention here. I didn't write what I did, but I explained. L of PV can be characterized by X and Y because the vectors and the point, both, are defined in 2 dimensions. But if you don't like X and Y, X, Y is a common way to represent the line, to represent the space. But if you don't like, you can put A and B. You can put Paolo and Ellen, my wife. I mean, this is a way to represent as in high school. No? We have the space characterized by X and Y. I don't know if you remember in high school. This means my representation can be done in X and Y. I mean, here we have X and Y as a vector equal 1, 1 plus T, which multiply 1, 2. Should I write in the piece of paper? I show you. Probably is I skipped some nomenclature. Let me show you again. Let me copy here. 1 second. Huh? Let me. Okay. LPV, as I told you, is P plus TV, right? For each T belong to R. Now, what is P? Is 1, 1, right? Do you remember? P is 1, 1. What about V? You remember?
-1, -2.
Right, no? Look. This from the definition. It's from the definition. Now, basically, the exercise is already there because the definition is applied. But very often in application, we need a more explicit expression of the line. And if you remember in Gymnasium, if you have the dimension 2, I can write everything in an environment with X and Y. With X and Y, in which, look, I can write, this is the trick. Here, X and Y equal 1, 1 plus T. I don't know if you like this way to represent. This is the set, please pay attention, is the set of elements characterized by this point and this direction, or better to say, parallel of this vector. Direction means same direction, but means also opposite direction, t positive and negative. This is the set. Why is the set? Because t could be any value. But we are in two dimensions, dimension x and y. If you want to call x and y, if you don't like x and y, you can call a and b. It doesn't matter. But we are in the room of dimension 2, which can be called x and y. This is the solution. I can explicit more, yeah, of course. I can explicit y is a function of x. Do you remember in the gymnasium? Why that? Because this expression means, please pay attention to the definition, that this vector here on the left must be equals the vector on the right. But this means both components, do you remember, must be the same. Now, we did this exercise also today, the sum of two vectors. This means x equal 1 minus t and y equals 1 minus 2t. Please pay attention now, more explicit than in the slide. More explicit than in the slide. I have this. Because both must be satisfied to have the equality principle or the equality definition. All components must be the same. Equal, must be equal. For somebody is boring, but I will repeat basic knowledge. Did you agree this? Now, if I want to explicit y is in the function of x, what I can do? What do you think? We have 3 elements, x, y, and t, and 2 equations. This is possible. No, hopefully. It is easy to consider, or to solve. Let me say in this form here. These 2 equations in terms of t. In terms of t means eliminating t. Look, from here I can write t equals 1 minus x. Did you agree? Combining with the second expression, I have this. This means y equals minus 1 plus 2 times 6. I hope no mistakes, no? Time. I made many mistakes. And then you can draw this. No? You can graph, as in gymnasium. Should I do it? I don't do, I come back on the lecture. But before going back, this definition allows us to say that I can use this. For instance, if t represents the time is in the sense is just positive. I can represent with this system here the movement of an object on the space characterized by x and y. I can do that. Because if you look at this equation here, we can see that at time 0, I have the position 1, 1. At time 1 second, for instance, if everything is in second, could be also hours. That depends on the unit which I use. At time 1 second is 0. The position x is 0. And here the y is 1. We can see that I can represent an object which is basically moving over time. with constant velocity, which is the velocity for x is 1. Or better to say -1, no? Because it's going back. From 1 is going to 0. No? What is the velocity for y? -2. I don't know if it's a possible interpretation of what I'm doing. Uniform movement. Did you agree a little bit? I can see this exercise also in a possible application to describe a uniform movement of an object in accordance with the two velocities, one through x -1, one through y -2. And in the space, I am moving. Let me share the presentation again. Yeah. At the beginning, as I told you, I am here at the point 1, 1, and then I'm going down in accordance with the velocity -1 for x and -2 for y. This is a possible interpretation of this possible exercise. Question at all. P and V can be interchanged. I mean, I have the same line if I say V is the point and P is the vector. No. This clarify is one thing is the point, one thing is the vector. Even though the point can be represented in form of a vector, but the vector is much more than a point because characterized not only eventually a point, but can characterize also the direction. If you do at home this exercise here, in which you can put here t here, please pay attention, t here as if p is the direction and v is the point, we have a different solution. Believe me, it's easy to see. This means when we say point, even though point is representable as a vector, but point does not characterize the direction, even though a vector is. In fact, here I used, in order to clarify this concept here, and the exercise, excuse me, where is with direction v. In the definition, we have a point, but if you remember, point is the vector. In order to clarify this point, this concept here, let me come back. Let me open the lecture, which you can find my study, lecture number 3. We will go ahead with, I think, some exercise and the definition of the plane and hyperplane. And exam exercise in any case. It's difficult, yeah, no, probably you already seen this in some courses or intuitively. I think it's interesting also this possible interpretation and physics, even though easy. Okay, the lecture looks like something like that. If you download, you don't need to download. Exam exercise directly. I would like to skip this. Let me see. I don't know. This is lecture number 3. Yeah, okay. Let me go ahead with this. We stop a little bit. We do some exam exercises. And then if I have time at the end, we will introduce a new concept, the concept of a plane, an hyperplane. It could be, we have 1 hour more or less, no? 1 hour, right? We will do 1 hour more. Exam exercise, please pay attention. Please show if the vectors are linearly dependent or not. I give you 2 minutes. Then we discuss together the solution. Intuitively, first of all, we have 3 vectors in dimension 3. No conclusion that it's not too crowded, the set. But intuitively, I would like to say they are independent. Do you know, it could be that you make mistakes. In any case, don't trust me, in any case. But the intuition could be also, intuition is not rigorous. No, I have an idea. Intuition means I have an idea. But why I have this idea? Because you remember I told you before the presence of zero. Do you remember the concept of the presence of zero? It seems to be the zero. We have a couple of zeros. Without looking in detail where the zeros are, but it seems to be that we have a couple of zeros in there. In particular, pay attention what I am saying. These 2 zeros here allows me to say in the middle, allow me to say that probably I generate the vector 0 with parameter alpha 1, alpha 2, alpha 3, all zeros. But this intuition could be wrong, could be also wrong. Could be also wrong. Intuition could be also wrong. I give you a couple of minutes. At least try to apply the definition, and the calculations could be a little bit boring, but not so difficult. Not so difficult because exactly in the middle, we have a forced condition. I don't know if you see it as 2 times alpha 2 equals 0. This means we have a directly alpha 2 equals 0, and then we will see what happens for the rest. I don't know if intuition is correct or not. But it seems to be, in my opinion, it is so, but I can make a mistake. So go ahead. We are too tired, also mean. Look, definition. Without repeating the definition from the you will find the definition on the data sheet. This means you don't have to write the definition again. Directly. Apply the definition. 0, 0, 0 equals alpha 1, 0, 1, 0. Let me read. Plus alpha 2. Oh, I made mistakes here. No, it's correct. 1, 2, 1 plus alpha 3, 0, 0, 1. This means, look, directly, as I told you, directly from the second equation. Did you agree here? From the second equation, this, I told you before, from the second equation, alpha 2 equals 0. Did you agree? Also in the exam, try to write directly what is directly visible here. Okay, you can write as you want, but here directly we can see from the second condition that 0 equal 2 times alpha 2, ready. This means alpha 2 equals 0. This helps the exam to go ahead a little bit fast or faster, more fast, because you remember I told you to get 1,0 we have to achieve 90 points, so the credit points. We have more than 90 credit points at disposition, but everything is calculated considering the time criterion. Each point, do you remember last time I told you, is calculated, it is considered that one point or the credit point should be or the must be, if we want to 1,0, obtain in 1 minute. This means the reason is we have to the reason is you have to do exercise. You have to do exercise. Alpha 2 equals 0. Now, look, from the condition number 3, we have 0 equals alpha 1 plus alpha 2 plus alpha 3. From Let me see. I hope no mistakes. No, no, excuse me. For the condition number one, excuse me. For the condition number one, we have the condition number three. I told you this is here at the end. But let me see this here. Zero. I told you correctly. The condition number three is alpha 1 plus alpha 2 plus alpha 3 equals 0. But why I put here directly the condition number one? Because consider the condition number two, which I already explained, considering the condition number one, which says 0 equals alpha 1 plus alpha 2. If alpha 2 is equal to 0, I have directly alpha 1 equals 0. Now, I obtain alpha 1 equals 0, alpha 2 equals 0. If I consider, as I told you already, the condition number 3, I have also alpha 3 equals 0. My intuition is validated by the calculations. The vector are independent because each alpha I equals 0. Each, or the all, if you like. Difficult in the exam? Typically, I don't remember here, I give 3 credit points, but you can realize in 1 minute you can do that if you do an at-home exercise. Because it's a shame also math is also feeling, and the feeling is built of the doing exercise to see immediately what happens. Look at this. We know intuitively, directly, because this set here is dependent. Why that? Because we have 4 vectors within or inside the dimension 3. But in the exam, it's not enough, this sentence. You have to justify mathematically. I don't know if I ever had a solution. I have it. I mean, but this consideration will help you because you know already what we are waiting for. When we know in advance where we are to go, it's clear it's easy the travel. It's clear, no? What I intend. If we don't know what we have to go, the travel could be also problematic. No? I give you a couple minutes and then we will look together the solution. I would like to tell you before to go ahead, think about if a set of vectors, excuse me, includes the vector 0. Think about this concept here. Before go ahead with this example here as an exercise. If a set of vectors includes the vector 0, is the set dependent or independent? This is a particular case which I will discuss, but if you remember the definition, we can answer. It's a trivial case. In fact, until now, I didn't include the vector 0. No? You understand what I intend? Look here. If instead of the 0, 0, 1, I put 0, 0, 0, is it in your opinion dependent or independent? It's the exercise of which already did, but instead of 0, 0, 0, excuse me, 0, 0, 1, I put 0, 0, 0. Basically, I include the vector 0 in the set. Or if you want, I can please keep these 3 vectors and put 0, 0, 0. But it's better if you consider 0, 0, 0 instead of 0, 0, 1. Is dependent the set or as independent? Here, please, was independent because all parameters were 0 or the are 0. If here I have a 0, 0, 0, what happens? What happened here? Dependent. This means each set which include the 0 vector is a dependent set because alpha 3 could be everything. But of course, it's in a trivial case. Understand? It's in a trivial case. We didn't include 0 in the set explicitly. Huh? Just to discuss with you. Again, this was the exercise, or that is the exercise. Let me show you the solution. We have to demonstrate that they are depending, right? Or dependent as you want. Here's a demonstration. We can see at the end that we have two conditions. Let me express in this form here. Alpha 1 equals alpha 2 and alpha 4 equals minus 2 alpha 2. If you do at home the calculation, or if you look at the calculations here, I show you now. From the middle calculation, we can see now that alpha 4 equals minus 2 alpha 2. This already says as something. Of course, it could be that through the calculation we obtain alpha 2 equals 0, but it's not the case. Will not the case. Going ahead with the calculation, we have also another condition. Alpha 1 equal alpha 2. Even though we have alpha 3 equals 0, but we can see not for all parameters, alpha parameters equal 0, we have to generate, we generated the vector 0. Here a little bit boring to do, but it's easy to see. Try to do a little bit at home these boring calculations, but it's not so difficult to do this calculation. Look at this expression here, nevertheless. This is important to discuss. This is the definition of the dependence or independence and so on. Huh? I can write the same exercise, or I can verify. Please pay attention. I can verify does the vector which I am considering are depending. Using this form here. Why that, in your opinion? The reason is I can consider the set of elements which already defined, and in this form here, I try to test if I can find one of them, it doesn't matter which one of them, it doesn't matter which one, as a linear combination of the rest. I mean, this expression here is equivalent to this one. Why that? Because it's as if I put this expression here on the left part with minus alpha, which multiply 1, 1, 1. And then I divided everything by alpha, if alpha is not 0, assuming this, if alpha is not 0. And then I renamed everything with the new notation alpha 1, alpha 2, and alpha 3. But independent of this mathematical trick, the idea is when we say that a set is depending, I would like to show you this, consider the words depending or the dependent. This means they have relations. Depending. I depend on Atlas. I depend on my, I don't know, university. This means we have a relation. in the relationship with a person, no? It's the same. I look if these four vectors, they have a not trivial relation. This means I will check if these three vectors generate this vector here. This expression here can be interpreted in this form. But believe me, you can choose whatever vector here, not necessarily 1, 1, 1. We test here if we have the relation between these four vectors. What is the meaning of the relation? If exist alpha 1, alpha 2, alpha 3, not 0, not all 0, which I can generate 1, 1, 1, given the rest of the set. But this can be done considering any kind of vector, let me say on the left part, no? Any kind of vector of the left part. It's clear what I intend. It's not another way to verify that these four vectors are depending. In fact, we can see that I can generate using alpha 1, alpha 2, alpha 3, which we don't have all 0, the vector 1, 1, 1. 1, 1, 1, 1. The calculation is the same. 1 equals alpha 1 plus alpha 2. 1 equals 2 times alpha 2. 1 equals alpha 1 plus alpha 2 plus alpha 3. Doing the calculation, we can see that alpha 2 is 1 divided 2. If I plug in here alpha 2, we have alpha 1, 1 divided 2. And then if I plug it in the equation number 3, we have alpha 3 equals 0. Just 1 alpha is equal to 0. I mean, I find the solution. I made a little bit mistakes in this sense. If I find the solution, before I told you something not correctly. When I say they are not 0, I mean, we find alpha 1 and alpha 2 and alpha 3, we generate, given the vector, these three vectors, the vector 1, 1, 1. But this vector on the left part can be one of the vector of the set, not necessarily 1, 1, 1. Doesn't matter which one. Please, I made a mistake before, no? Alpha 1 and alpha 2, alpha 3 must exist. To say they are dependent. Because I generate with the rest of the set whatever vector of the set. If you want, I can do an exercise in this form here, but it's not important because in the exam you can solve, you can answer me directly applying the definition. But this is not a way to explain the concept of the dependence. I generate one of the vector in the set. Consider the rest. Which one? You can choose whatever you want. If you want, I can do an exercise, but let me go ahead. Quickly. These two vectors of this set, dependent or independent? Clear, dependent, because they have the same direction. Here's the demonstration. For alpha 1 equals minus 2 alpha 2, I generate 0, 0. And not all parameters are 0, because alpha 2 could be whatever you want, not necessarily 0. This, we already did this exercise on related to this to the line. This means we'll go ahead, but we try to do together this now. Find the line now is more explicit in the exam, in the exercise. The line characterized by x, y, z, 3 dimensions, dimension 3, passing through point P, 1, 1, 1, generated by vector V, 1, 1, 1. Here, the points and the vectors, let me say the same. This means no possibility to formally yes, but practically to make mistakes if you invert the row. Apply the definition. Right. Correct. X, Y, Z equals t which multiply 1, 1, 1 plus 1, 1, 1. This means x equal t plus 1, y equal t plus 1, z equal t plus 1. Now, with this last slide of this presentation, we can see the concept of the plane. But in the next presentation, I will show you what the plane is more formally. The definition is clear, no? This is L parenthesis P comma V parenthesis equals on the right part as before. But more explicitly, we are speaking about the dimension 3. This means we can represent in X, Y, Z, everything. This central expression is clear. I didn't put here the link, the parenthesis of these three conditions, but it's clear. You can imagine that they have that these three conditions must hold together, no? For the equality of a vector. All components must be equal. Look, combining, if you like, the first two equations, I have x equal y. Clear, no? I mean, how I can eliminate t? Do you remember the idea to represent in geometrical form? Because this expression here, x equal t plus 1, y equal t plus 1, z equals t plus 1, is the physical expression. If you think about my possible interpretation that we have an object which is moving with velocity along x1, with velocity along y1, with velocity along y and z, the velocity is the parameter which multiply t. It's a possible physical interpretation, not a unique one, but easy to understand. It's the physical way in which t could represent the time. If you combine now the first two equations, I have x equal y. Did you agree? If I combine the second and the third equation, I have x equals z. Did you agree? Now here it's more important to emphasize this parenthesis. In any case, also here. But I didn't put. Because we will see now, if you are not tired, that x equal y is the plane. And x equals z is another plane. And if you remember in gymnasium, this symbol here, as I told you, so here I didn't put, but try to imagine. These three conditions must hold together. But if these three conditions must hold together, these two conditions came from these three conditions which must hold together. This means these two conditions must hold together. This line, which is here, x equal y equal z, is the intersection of two planes. Do you remember the line in the set? We will see now that the plane is also in a set. The intersection of two planes is in a line, if the intersection exists. Intuitively, this is the plane. If this is another plane, if they have an intersection, in between you have the line. It's exactly what happens here. Let me see if I have a picture for you to show you what I intend. I have a very few, but I am not able to find. I have. Is not the same exercise, but the solution is the same. I don't know. It's the picture of this exercise, excuse me. It's the picture of this exercise. I show you. Let me show you. It's the picture of this exercise. Look, x equal y equals z. I try here to graph in system x, y, z. X, let me, Y, Z. Then I don't know if it's visible, these two planes. We have in a blue plane, which is characterized by Y equal X or X equal Y. I will try to explain later. And then we have in a red plane, which is characterized by X equals Z. Let me see if I'm able to explain, to interpret what I intend. At the intersection is this line here. Let me show you. Let me try to explain. The blue structure is easy to see. I mean, what is the meaning of X equal Y? The meaning of X equal Y, if you remember in gymnasium, can be interpreted as a line, let me say, in the plane XY, let me say in the middle between the two axes, X and Y, because for X equal Y, 1, Y is equal 1. This means in the plane XY is this line here. Y equal X in the plane XY is this line here. In the middle, let me say. The second of the quadrant X, Y. But Y now in this representation is in a plane, which is going up. I don't know if it's visible. I mean, Y equal X in the plane with dimension 3, X, Y, Z, is the trace of the plane, which we can see here in blue, on the plane XY. Is the intersection for Z equals 0. I mean, Y equal X in the plane X and Y is the intersection of the plane Y equal X for each Z, the intersection for Z equals 0. Because I have this line here. If the plane which is going up, let me say, for each Z, because Y equal X means for each Z. Z is not specified. In fact, if Z is not specified, all points which belong to the plane, which you can see here characterized by, let me say, the intersection with the plane XY, belong to the set, because set here is not specified. I don't know if this could be seen. Let me try to explain a little bit better. Let me try to explain this a little bit better. Think about, for each set is clear, huh? Because if you consider just this element here isolated, X equal Y, for each set, like here, X equals Z for each Y. If you consider just this expression here. Now, I try to draw this expression here and this expression, and then to show you the intersection, because this means the intersection. If this means X equal Y for each Z, this means parallel to Z. I don't know if this concept was clear also before. Do you remember? If I write this means independently of Z. Let me see if I am able to show you this a little bit better. How I can explain more visually. It's difficult to figure out, probably. Because if Z is not included in this expression here, this means that the plane does not depend on Z. This means that the plane is parallel of Z, like here. Y does not appear. This means for each Y, let me show you this red. Let me see how I can see that a little bit better. The line is this here. It's, I don't know if it's visible here. The plane is parallel to Z. I made mistake before with the red and blue, both as blue, excuse me. The line is this here. X equal Y, excuse me, X equals Z, the line is this here. The line lies on the plane X, Z, and Y equals 0. As the line, because Y can be C also equals 0. But in the plane, in the space, this is the trace of the plane on with intersection with the plane XZ. And I don't know if it's visible here. Something which includes Z, because we don't have constant here. I mean, X equals 0, Z equals 0 are here. This point here. And then it's parallel to Z. This means include in the sense. Excuse me, parallel to Y, include Y. And the intersection is not so easy to see, but it's X equal Y equals Z. Because X equals Z, X equal Y, analytically is clear, no? Analytically is clear. Graphically, it's a little bit more complicated to see. No? I mean, you don't have to draw graphically in the exam. From here to here is clear, no? Because X equal Y, X equal Z, you can conclude Z X equal Y equal Z. This line which is coming out, let me say from this point here. Let me see if I can add some possible interpretation on this parallel axis. I think, I mean, the meaning is this one. This is the plane parallel to Z. In this case, include Z because we don't have any constant here, because X equal Y implies also that the origin belong to the plane. And then if this point origin belongs to the plane, if considering that for each Z means parallel to Z, it's clear that the plane at this trace on the plane XY is going up, no? Parallel to Z, which includes in this case Z, because it's independent of Z. Let me do something. I will come back probably when we have the definition of the plane more formally. Let me upload 10 minutes, right? Let me upload the lecture number 3. No, this is the lecture number 3. The next. Let me see which lecture. The lecture number. Let me see. 4. Right. Yeah. Let me go to my study again. In any case, I will generate the folder of next time. So we will introduce today, but we will go ahead next time. Huh? Okay, let me share this so we can see what I am doing together. Next time is 20, no? Right? Right. Okay, we can see here the lecture number 4. Okay, you can find this. The lecture number 4 looks like, let me show you. And then we will go in depth on this parallel and so on. Huh? Probably next week, but let me share, let me share. Session 4, no, the lecture 4. Hyperplanes and exam exercises, very well. But exam exercise we will do probably more in depth next week. Hyperplane, we discussed also before starting the lecture today. Hyper means more, very large. But did you find it? Do them hypersonic, hyperuranio, hyper in English, no? When we speak about hyper, when we cannot draw, if you have more than 3 dimensions, big dimensions, so hyper. Otherwise, plane is enough. But in some books, they speak always about hyper, independently of the dimension. Definition of hyperplane, of an hyperplane. An hyperplane H, included in R up to N, is a set, again a set. Have you ever seen? Also with this graph is in a set of points. No? x1, x2, xn. Very often when we have a dimension n, we can use xy, z, w, v, n. x1, x2, x3, xn. This point, this set satisfies a linear equation, x1 multiply x1, a1 multiply x1 plus x2 multiply x2 plus dot plus an multiply xn equals b. With ai not 0 for hi and b a parameter. Look. Next week we will go in depth. Look at this. In R1, let me say, or R up to 1, the plane or the hyperplane collapses in a point. In this sense, the point is also a plane. But it's in a plane in R up to 1. It's in a collapse. A1 multiply x1 equal b is the point. If a1 is given, if b is given, x1 is a multiply a1. Is the point. Of course, we can speak about hyperplane, but just to show you how starting from a point, we can build the line, from the line we can build a plane or the hyperplane. If you have more than 3 dimensions, we speak about hyperplane, but we can also coming back. we have room and plane, and then we come back to line and so on. We can see the line, in fact, if H, this set of points, belong to R up to 2, we have this expression here. This we know that. You remember, A1 multiply X plus A2 multiply Y equal B. We have seen it today. This is the line. Instead of X1 and X2, I am calling X and Y. We have seen also today that this expression represents a line. You remember? I don't remember, was Y equals minus X plus 1. Something like that. In which B equals 1, and the rest we can. In order to understand that this general, this expression is a general expression for everything. Dot. Exam exercise. And then next week we will go in depth of interpretation, different expressions and so on. Here, 10 minutes, we do 2 exam exercise. 2 or 3, I don't remember how much I have. 1, 2 exam exercise. Then we will close. Next week we will go in depth. Look at this. Calculate the plane or the hyperplane. But until dimension 3, we speak about plane. Such that point P equals 1, 2, 3 belongs to it, the plane. And the plane is orthogonal to the vector V equals 1 times 3 minus 1. Ideas, intuitively, look at this also at home. Look at this. We have a vector. Please pay attention here. Look, it's a little bit strange, but I will try to figure out if the problem is consistent or not. Consistent means if you can find a solution or not. You have a vector. Look here. This is the vector 1 minus 3, 1, for instance. This direction here. The vector is in a direction. It's not a point. This red pane is this. This my pencil is the direction. 1 minus 3, 1. I'm looking for in set plane orthogonal to this. Intuitively, orthogonal to this. Could be this, could be this. All plane parallel to this. Could be. I need another condition. Its position. Could be this, could be this, could be this. This means the problem is well posed. It means we will have a solution because the orthogonality fixed in a direction. I mean, once I have this vector, I have this, could be this, could be this, could be this, could be this, but let me say, I fix the orientation. Now I have just to fix the position, but I have a point. This means the problem is consistent. Let me show you the solution. One possible solution, and then next week we go in depth on different way, probably more, a little bit more intuitive to find the solution. What is the meaning of orthogonality between two vectors? V, which we know, multiply x, y, z equals 0. This is the orthogonality. But x, y, z represent the room, or let me say the set, not exactly, but at least the room of the plane. I mean, x, y, z should, or must belong at the end on the plane, to the plane, I mean. Did you agree? V scalar x, y, z, which at the end must belong to the plane, must be equal 0. I am looking for x, y, z, multiply in scalar sense by v equals 0. V I know. This means, you remember the definition of the dot product? This multiply x plus this multiply y plus this multiply z. for the orthogonal condition. This means orthogonal. I will obtain this expression. Clear? The definition of orthogonality. I apply just the definition without fantasies. Exactly what I told you. This is the plane which have the same orientation with our plane. Our plane means the plane which I'm looking for. I don't know if it's clear. This expression here is in the plane. We have the same orientation with our plane. Our plane is the plane which I'm looking for, but it's not our plane yet. Because this plane here is passing through 0. We can see for x equals 0, y equals 0, z equals 0, 0 belong to the plane. Do you remember the concept of belongingness? Which I applied, I told you just for the line, but can be applied at every set, at each set. But if you remember the definition, of the plane, which basically is A1 multiply X plus A2 multiply Y plus A3 multiplied Z equal B, we can calculate B because this is enough to impose that our point, which is here, 1, 2, 3, belong to the plane, and we calculate B. And B in this case is 3. Yeah, 4, excuse me. No, I don't. Minus 6 plus 3 is minus 3, minus 2, right? B is minus 2. Next week, I will show you a way to, if you want, I can do exactly now. In a way to solve the problem, probably more intuitively. Look. 5 minutes, 5 minutes. I show you the solution more intuitive way, and then I sketch the next exercise, and you can do it all. Huh? More intuitively. Probably here is more too complex. I don't know if it's, but here recalling the definition. Look at this idea to proceed. Help me to write the problem. Calculate the plane or the hyperplane, doesn't matter. H such that point P, what is the point? 1, 2, 3 is the point. 1, 2, 3, yeah?
Yes.
Belongs to H, excuse me. And H, let me say so, orthogonal, the vector is V equals
1 minus 3, 1.
now solution. Possible solution is 1, in this case, possible approach. If X, Y, Z represent the, let me say, the general space coordinates. Gesundheit. In R up to 3. Then X minus 1, comma, Y minus 2, comma, 3, excuse me, z minus 3. What represent this? In your opinion, excuse me. In your opinion, what represented this? X minus 1 that represent x, y, z minus p. If you want x, y, z minus 1, 2, 3. This means somehow I translate it in my, let me say, original point, my system. I don't know if you can, at the beginning I have here 0, 0, 0, and now I have 1, 2, 3. This means now my new system, or my system X, Y, Z, includes 1, 2, 3. My new system include 1, 2, 3. I mean, let me show you what I am doing. X apostrophe, Y apostrophe, Z apostrophe. I have a new reference which includes 1, 2, 3. Before I included just 0. Now it's ready. Because my system, which include 1, 2, 3, this means 1, 2, 3 belongs to this system here. X apostrophe, Y apostrophe, Z apostrophe must be orthogonal. I mean, the new system, X apostrophe, Y apostrophe, Z apostrophe, includes my point. I don't know if it's clear what I intend. Or better to say, the point is included here. It's clear what I intend here. The point belongs to the system here. If I put, in fact, x equal 1, y equal 2, z equal 3, I have exactly 0. Belong. This means now the condition is, I'm concluding, z apostrophe, y, x apostrophe, y apostrophe, z apostrophe, scalar. V was 1 minus, again, 1 minus
1 minus 3, 1.
1 minus 3, 1, yeah, right, equals 0. If you do this calculation, you find exactly what I already showed you before. This was x minus 1, y minus 2, z minus 3, which multiply all the scalar. Minus 4, what one B was minus 4? Yeah, I don't remember. Minus 2 was? This means we have an error. Let me see. Here, I don't see error here. Let me see in the slide. No, it's the same. We have minus 6.
But 1 minus 6 plus 2.
What is the error here? What is B here? You're right. Here is B is minus 2. This means is we have an error here. Ah, clear. The error is we have an error here somewhere. I don't see the error here.
It's plus 3 and not minus.
I don't see the error here.
It's x minus 3y plus b. And then it's 1 minus 6 plus 3. And you have minus 3 at the end, I think.
But here we have plus 3. Ah, okay. Minus 2, right? Now it's correct, no? Yeah.
And then 1 minus 6.
Ready. This is ready now. It's exactly as before. No?
Yeah.
B was minus 2. Do you remember? This is B. On the right part, we have a B minus 2 as before. I made mistakes in the calculation. 1 minute to formulate the problem and homework, exam exercise, of course. Look at this. For the plane generated by vector V1 generated. Now we already analyzed this word, generated by the vector V1 and by vector V2. You remember, in the line we had just one generator. Just one generator. For a plane, it's not a surprise, we have 2 generators. It's the point. This means, I concluded with this, the solution is in the slide, but try to do at home. I have 2 vectors, blue and line. We orient the plane, but to fix the plane, I need a point. This means it seems to be that the problem is well posed. I orient somewhere my set, and then I fix with a point. Try to do alone, and then check your solution as an exam exercise with the solution which I proposed in the last 2 slides or the last slide. Okay, we are ready. If you have questions, I'm here for questions. I try to upload all material. I have many exercises, but I don't find each time. But the exercise is already, the exercise are already in the slide. Now we can see this is exactly what I will. Next week we have just 1 block. We will go in depth on this hyperplane exercise analytical. We recap a little bit the solution, the exercise until what we did until now. Probably I have to introduce. I don't remember the next step. Optimization, or let me see what I did the last time. Not necessarily we have to do exactly as last time, but it makes sense nevertheless. Okay, if you have questions, I have here. In the meantime, I have to stop recording. Let me see. Yeah.